So now let us quickly try to do a problem and see if we can run it in the time allotted. So we'll do a simple 2D planar problem. So you'll have 2D planar, you have a deformable part, you will have a shell structure. Now here you can see that there is no extrusion, sweep and everything is coming because we are just talking about a 2D problem, a 2D problem in which there is just a kind of a plate. So the problem will be this I will give you so if you can understand what this is happening. So yeah, so this is the problem which we will do a very basic problem. So you can see this is a dimension here, this is a part of the geometry, this is a so you use its dimension but we'll use our own unit, we'll not use we'll probably do it in our own unit, okay, and young modulus and everything will use as our own unit. So let us just make this geometry. You can see this geometry is 6 by 12, 5.5, 1 and 5.5 and this is 12. So this is a 6 by 12 geometry. So let us just make this geometry. So now here you can see sketch the section for the planar shell. So you will have simple rectangle and it will ask pick a starting corner for the rectangle. So let us just suppose that uh, you pick a starting corner as your this origin. Now it asking pick the opposite corner for the rectangle. So you'll have 12 by 6. So now you can have this rectangle ready. So what I can do is that I should select less size. Okay. So instead of 200, let us just select 20. So it might come a bit big. So we'll have this. The first one is the origin 0, comma 0. Second one is 12, comma 6. So now you can have this your rectangle. Okay. This is going out. So you just do this reset view. So we can move this. We can move this part from where translate, move the entire entity. Select, then pick a starting point. Let us just pick the starting point here. Pick the end point here, and now it has come. So it has come more on the screen. Okay. So now let us just or perhaps our dimension has gone wrong if we'll do this. So let us just continue with this. Okay. And oh no, I have done sketching before. Again, we have to go to the sketch. No. Oh, gosh. Sorry. Got There is a back command. It's not Control Z here. I have to see which one is the back command here, because every time, anyways, just quickly do it. Let's keep it. Just quickly do it. This step 0 0 opposite side 12 comma 6. Then you'll have another rectangle here, because the geometry, if you'll see this geometry, we'll draw another rectangle in this part. This rectangle will be 2 by 1, and then we'll trim the remaining part. So it will be, pick the starting point 5.5 comma 0, 5.5, because you can see in the figure that from origin it is 5.5 this. So the rectangle will start here and it will move 2 mm upward. Okay, this, and it will go 1 mm in the horizontal, 2 mm upward, 6.5 comma 2. So now you can see this is your rectangle. So now what we have to do is that we have to remove this particular part. So we'll do the auto trim. This part is gone. Okay. So now this part is gone. This is our thing ready. Now sketch the section for planar shell. So now we have our planar shell ready. So we'll go and see step by step, and I'll also explain each step for you. Okay. So the next thing is to assign the material, or before that I'll give you this particular copy, and then I made it, so you can take this. So you already have the thing assigned. Now we will assign the material. Okay, so let us just assign the material. You can see in the material they are assigning density and the elasticity, and they are doing the elastic part. So this is not a plastic deformation, this is a simple kind of deformation. So material, you can go from here, you'll double click, you'll get into the material. In the mechanical, we will see the elasticity and we'll see the elastic part. So I have already told no compression and no tension, so that will be whatever. So you can say it's a 210 GPa. Maybe we are taking the steel, let us just say steel. So steel, it is 210 GPa, and the so here one thing which you need to understand, that generally the material properties are different in compression and tension. So if a particular application is there where there is also compression and there is also tension, so you have to define the elastic and plastic material property two times for the same material. And once you will, suppose you are describing here steel compression, you are naming the material. Okay, and steel compression, you will do here, you will put the Poisson ratio and you will do no tension. So whatever it is going to take the property, is going to take the property only at those places where compressive stresses are acting. And similarly, one will be okay, then you will apply to steel tension. So then you will put no compression here, and you will apply over there the property that will be the property in steel tension. However, we will not give this, we will do it, or we will assume that it is in compression and tension, it is same, and the Poisson ratio is whatever, let's say 0.3, and number of, we don't have the use temperature dependent, and everything. Let us just give the density also. So density of steel is 7.85 or maybe 785,000 in this unit. Okay, and then for this application, of course, the plastic is not needed. So now when I was teaching you about the material properties, you can see that I was teaching you for all these things. Okay, so but here the plastic is not needed. The only thing which is needed is the elastic property. Okay, we are not talking about the thermal side. We are not heating the component. So therefore you have to here understand that although I have taught you about all these properties, but for not all application all properties are required. Therefore it is a duty of an engineer to understand that which property is required for which application. So this much is enough for us. See, simple application, we have only given elastic property and density, and there are so many properties there. So we'll do okay. So now the property is assigned to the material. Now you can see here that the next part which they are going to do, they have assigned the property to the material. Now the next part they are going to do is they are do the section. So they will sketch the section for it. Why do we sketch the section? So here you have already told that you have made this, but you have made it in space, you have not given it. So you have not given it the property to the material. You have given the property to a software, but the software will not realize that the property is going to home. So you have a section which is a solid section, homogeneous. So it's a homogeneous section. You'll do it. You'll have this material steel in tension. You'll have the thickness. Suppose 1.5 mm is the thickness, and you'll put OK. So now the thickness is applied to the material. So now the next step we are going to do is that we are going to assign the material. Okay, assign the material. So assign the material there in the section assignment part. So let's go to the section assignment part. It is in the part here. Yeah. So here you have the section assignment part. Now here you can see select the region to be assigned a section. So now you have to select a particular region. So let me just select a. Suppose that I'll be selecting one. Suppose that you want to have a composite, one region having a different section, another region having a different section. So if you select it like this, you cannot do that because all the region will be selected at once. So you have to partition it. You have to partition the region while making the CAD geometry. Okay. So all this, therefore the making of the CAD geometry becomes very, very significant and very important. Okay. So you will make it and you'll select the material. So you have selected the material, you have the section 1 assignment. You can see type is solid homogeneous, material is steel section. You'll put OK. So now you can see that the material property is already being assigned. In section assignment, select a region to be assigned. And then now you have to go in from the property module, you have to go to the assembly part and click instances. So assembly part, then here you'll have to click instances. So you'll go assembly here, you'll have to click instances. So you'll have the part is dependent, it is not independent. So it is dependent on the mesh, that is what you will select and then you will put it OK. So now this OK is done. So the part is now mesh dependent. So you have to do the whole part as a mesh dependent. Now these features you don't really need the position constants because we are already doing the static analysis. So the position is already constant, it is not moving. In the dynamic analysis, sometimes we need this kind of features. Now, after that, assembly part will go to the step. Okay, in the steps, you can see that you have to assign what kind of problem it is. So this is a basic static general problem. So that what I have told you previously. So in the step uh, there, you'll have initial. Okay, initial, static, and general. So there are different type of problem, whether the problem is dynamic, temperature dependent, whether the problem related to the heat transfer, whether the problem is related to the soil mechanics and all. So you can see all these kind of problems are there. So we'll have, you can have dynamic, implicit, and explicit. This is also has a meaning, implicit and explicit in the finite, but right now I don't have time to do this, so we'll do it continue. So now I must tell you that I have gone beyond CAD. Now I'm telling you the FE modeling and everything. So here, when you'll do the edit step, it is showing NLGEOM. So NLGEOM, you have to keep as off until and unless you can only keep on when there is a non-linear analysis. Okay, in the linear analysis, you have to keep off. And similarly, the time period. Time period is again in the static analysis, the time period is not needed because it's an static analysis, it is not dependent on time. So whether you give 1 or whether you write 100 over here or whether you write whatever 0, we will not have any impact on our result. So agar hum, if we'll do like this and then we'll put OK and then we'll run, then also we'll have the same result, and if we'll put it just 1, then also we'll have the same result. However, when you are going to do it for the dynamic analysis, the time period becomes significant because the dynamic analysis changes with respect to time. Then the incrementation, you can see how many increments you want for each step. So whether you want 100 steps increment or whether you, so it depends on how fine you basically want to have your results. So that is what, so if you'll have 100 increments, means for every 1 unit of time it will give 100 steps of results. So more and more increments will get, have more and more final and final results you will get. Fine results accurate, but it will take more time for the analysis and it will get involve more computer memory. So again, this is something which is very critical for you as an engineer to decide that what is the steps of increment which you need. And then this is not required. Okay, so right now I'll just keep it to 10. Okay, and we'll put it okay. So it's okay. So the next step, this is selected. Now we'll go to the field output module. Okay. So the output module over here, we will see, we'll go to the, sorry, where, here we go to the output module and F output 1 we will click. Now here you can see this works for the whole model and frequency is every n increments. And then you have given as whatever you can give 1 or you can give 10. Okay. So every 10 increments you will get your output, and there are many outputs which are there. Okay. Even within an output, these are the default outputs which Abaqus puts, which are needed for most of the applications and all. But apart from that, there are specific outputs. So within the default output, you have to go to stress, and then you have to this. You can see how many type, so many type of stress. So again, you as an engineer, it is your uh, to decide that which kind of stress you want. You want simple component stress, or you want one Mises stress, or you want maximum Mises equivalent stress, you want plastic stress and all. So let us just put generally on this. Then again is strain, which kind of strains you want. So jo bhi by default it's already there. So let us just don't touch it. Then the displacement translation. So what kind of displacement you want? Let us just see that will have the translation only. So UT will be there. Okay, the translational displacement. So again, that depends on what kind of output. So when an engineer is doing a certain analysis, so you have to understand that the engineer knows about the process. So you as an engineer, you have to have a very good understanding of the process. So if you don't have a good understanding of the process, then you will not be able to decide that and what increment we want our results, at what are the results which we want, what kind of stresses we want. So आप क्या करोगे कि सब कुछ सेलेक्ट करते रहोगे और आपको पता भी नहीं चलेगा और वो इतनी ज्यादा computational time, it will take so much of computational time. You will keep on selecting everything and it will take so much of computational time that you will really be gone. Your simulation will be gone. So if somebody does like that, then his senior supervisor will understand that okay, this guy has no idea about the simulation. Nobody select everything. Okay, just like I said that nobody put all the mechanical properties. Similarly, nobody selects everything. Similarly, force contact. Then you have the failure. What kind of failure you want? So this is a static analysis. That we are not going to the failure part. So you can see all these things. Okay. So then volume fraction. Other you have the thermal controls, nodal temperature, element temperature, whether you want temperature at the node, whether you want the temperature element, then you have the porous dimensional thing, volume, then you want this different kind of volume fraction, whether there is a porosity in your, okay, so all these kind of things are there. So you'll just put okay, whatever is selected, we'll put okay. We have not selected any of these, okay, because these are not required. We'll put okay. So now once we have put okay, now we'll go to our, so it is written, this you will get, I'll send you this file. So go to field output module, field output one, and select the output you required. So now you have to go to the boundary condition. You have to give the boundary condition. So where is the boundary? This here is the boundary condition. So boundary condition, what kind of boundary condition? Basically you need displacement and rotation. So this is mechanical, this is displacement, and you have to give initial. Okay, so displacement and then you'll put create. So select the region for the boundary condition. So you will select this, then this, and this, and then this. This is the region which you have selected. So your boundary condition is set. Now, whether you'll give U1, U2, U3, let me see what is there. I think U1 will be closed. So we have selected the four corner. So U2 will be 0 here. So you'll have U2 which is closed, then you'll put OK. Now you'll have another boundary condition. So another boundary condition where you have to lock U2. Okay. Sorry, U1. So we'll have another boundary condition, initial, continue. Then you'll have to select this part, done, and then you lock U1, and then you'll have okay. So now why you are locking? Because if you'll go to the initial application, you will see it's a roller support. So it's locked over there. It is not going to displace. This part is not going to displace in any dimension. Similarly, the upper part is not going to displace. Okay. So this is why it was locked. So you have to understand the mechanics of the process. That's what I told you in the beginning, that you have to have a complete, just by the learning the software nobody becomes an engineer. Okay, so you have to know the mechanics of the process, where you have to lock, where the dynamics is there and everything. So once you'll do, then you will click on load pressure. So you'll finally give the pressure. So you'll have step one, you'll give mechanical, you'll give the pressure over there. Let me see in the problem what is the thing which is there. So they are giving, you can see they are giving the pressure, not the force. Okay, so that is why we are over here, we are giving the pressure. So we are almost done with the time. So we are giving the pressure. So let us just select the surface. This and this. These two sides, the pressure has been given. So this is done. Okay, how much pressure you want, whatever the pressure of the magnitude, whether the constant pressure or changing pressure. If you want the changing pressure, you will give with respect to tabular, and here you will continue. So you will get a table. So there you can give the changing. Here, for the simplification of the application, let us give a constant pressure of 15. Now you see what. So this is a compressive. So the positive 15, they are taking it as compressive. In the problem, it is tensile. So let us just, what we do is that we will load 2 is there, step 1 initial. So let us just node 1, let's go. Okay, I wanted to show you something. ये उल्टा कर दिया मैंने. So now let us just select, just let's go a little bit different to this whole problem. Let us show you something on this face and on this face. So we've done. So now let us just do it as a minus 10 point, or whatever we have given, minus 15, I think. Okay. So now you can see that this is our final boundary condition. That is different to what our problem is. Okay. So this is our final boundary condition. So that is how the load is happening. Here it is going to stretch at the bottom part of it, and this part it is going to get compressed. So in the material we have already assigned no tension, no compression. Okay. So now finally we are going to give, for part mesh, we are going to mesh assign element type, and okay, dependent part. Again. Okay, there's some error here. I understood the error, but I don't really have the time to go into that. But I think the mesh part I have already told you. So let us just complete that part. Once we'll assign the mesh to the problem, there's a mesh part. There's an error here at the top which we have to do it. Okay, position constant. Okay, okay, 1 second. Yeah. So now we can assign the mesh. We can see approximate global size is apply 1. So we'll just give 1 and you can see this is how it is. So this part I have already told. Mesh part. Okay, yes. So this is how the mesh is going to look. Okay. So once we have assigned the mesh part, now click on mesh assign control and then we'll see what kind of element we have had. Assign mesh control. We have the try. Okay. We'll put okay. No, so let's not rechange the mesh. Assign element type. So I'll select the whole region. Done. Element type will have simple standard linear. If we want to go to try, if we want to go quadrant, we have a 4 element. So let us just have the standard linear element and here we'll select the plane stress. Plane stress is a problem, two-dimensional problems. So we have a very minor thickness, so we'll have plane stress problem. I don't have time to tell you what is plane stress. So we selected this and finally we'll verify the mesh. We'll select the part. Okay, highlight. So you can see number of elements is 83. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12, 6 are 72, and then you'll count, you'll find total 83 elements are there. So that's fine. You can still remove again. That depends on you what kind of elements, how you are going to highlight that. And finally, once everything is done, you will click on job. So you'll click on job. This is create, continue. Okay, the job has been created. Then you'll see the job. Here you have to submit. So job submitted, job input, job completed successfully. Okay, let us just do the monitoring of the job and we'll see that we have given only one increment. So therefore the in one step the job is done. Okay. So just to complete it. Now let us go to the result and see this is what the impact of your overall thing is. Okay. So in the normal case it is like this and the step time we have given is 1, the increment is also 1. So I we should have given the increment as more. Okay. So in the first step, you can see that this has become like this. So what do we understand by this? We understand that actually we have not solved this problem. Okay. Because if you remember, I have given the tensile, compressive here and tensile here. Okay. So, so what we understand by this, that if I am going to give if I have this particular model and we are going to apply this much pressure in this direction, like compressive in the two faces and horizontal tensile in the other two faces, the material will not withstand the pressure and the material will fail. So if you are going to put this material into a certain application, okay, and that particular application is subjected to that kind of loading, so you will understand that that kind of loading the material will fail, material will not work. So either you have to strengthen the material, either you have to change the loading, or you have to overall change all these things. So this is the maximum stress which the material can bear, and then you can have different kind of, from here you can see different kind of results which you have selected. This is the magnitude, this is the translation magnitude, how much it has been, it has translated 0.32 mm. In the unit it has distorted 0.32 mm. So then all this in one direction, other dimension. So this is how it works. So this is basically the analysis, a very small example which has been completed, and I hope that you have enjoyed, you might have enjoyed the session. Anybody who have any answer, any query, they can ask, and
Yes,
then
sir.
we can wind up.
Hello. Hello, sir.
Uh, Nice session. Okay, thank you very much. And anybody
Hello, sir.
else?
Hello, sir.
Yeah, yeah. Tell. I'm listening.
Sir, after diploma in mechanical engineering and after completing AutoCAD and CATIA software, sir, how much salary we get?
Oh, it depends. It's on the job, you know. Just it really depends on the job, depend on the company. If you are going into a good company, generally 35,000 rupees, 25,000, 30,000 they are going to pay. If you are going to work as a solid modeling engineer, 25,000 maybe. If you have an engineering degree, and some of the big companies. So see, mechanical engineers should not only focus on solid modeling software. AutoCAD and CATIA is just a basic. This is for the diploma ITI guys. Okay, that's why this focus for those people who are in diploma, those people there, they should come up to the engineering. They should join engineering and they should make their career better, because diploma will not have very good job. Yes, the other guy, Mohammad
नहीं
Sadan Shamsi.
यस सर मैं अभी सर स्टील प्लांट में जॉब कर रहा हूँ ब्लास्ट
हाँ
फर्नेस में
हाँ
मैकेनिकल डिपार्टमेंट में सर लेकिन मुझे वो बहुत टफ लग रहा है फिजिकली
हाँ।
मेंटेनेंस में ही
हम्म।
तो सर ये डिज़ाइन से रिगार्ड्स कोई ऐसा जॉब कौन सा जॉब कर सकता हूँ मैं अभी सर बी मेरा कंप्लीटेड है और 3 ईयर एक्सपीरियंस है 1 ईयर टाटा स्टील में
So
और
you
1 ईयर
apply to the design profile, but then again, as I said that nowadays there are so many opportunities. So if you apply to the design profile, they will ask whether you have those soft skills or not. So this is what this whole workshop is targeted for. Okay, to make you realize that whether you have the soft skills or not. So should I said again and again that you should not focus only on AutoCAD and CATIA. This is at a very beginning level. AutoCAD and CATIA is being taught to the engineering students so that they can become well equipped in these softwares. These are the I mean, let's say this way, that the big boys do generally these kind of stuffs, finite element. And tomorrow,
दैट
that's why the two sessions are being kept on finite. Tomorrow also you'll see, and it will be very interesting.
Sir, that means for this for any job, sir, will have skilled in software.
You'll have to have it. The market is very competitive. Even those people who have the skill in software are struggling right now in the COVID scenario. But you have to have those skills. You have to, so not only now those, but apart from that, artificial intelligence, data science, data analytics, and all. So you'll have to have that.
Okay.
Okay.
सर तो
Yes.
बता दीजिए सर कौन सा सॉफ्टवेयर सीखना सही रहेगा जिससे जॉब मिलने में सर आसानी हो
At least
ऑटोकैड
you
और
try to learn one of these softwares, Abaqus and SIS. At least one of these softwares.
ओके सर
Okay. So I hope that you enjoyed the session. I hope that I have been able to teach you things which you did not knew previously, and I have been able to impart you the knowledge, and more importantly, I have been able to impart you, especially for the diploma student, I have been able to motivate them to come to the engineering and study the engineering, and those who are already in the second year or third year of engineering, they're motivated to learn these softwares and these analysis to strengthen their CV. So now I think we should stop our workshop. Tomorrow is the last day of the workshop, and again the same thing but different software and sys will be taught. Same finite element as I said. These are the big boys thing. The first, second, and third day is just the beginners thing, is more for the diploma guys and for the beginners. But this today and tomorrow is a thing which is for the engineers, for the big boys thing. So hopefully you'll attend tomorrow and you'll learn more of it. So let us just wind it now. Thank you very much.
हेलो सर
Hmm.
सर जैसे डिप्लोमा जो किया है तो सर उसके लिए ऑटोकैड और कैटिया सीखना सही रहेगा या फिर उसके साथ एनसिस भी सीखना होगा